Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon, ladies and gentlemen. Thank you, Mr. Chairman, for the opportunity today to presenting our study. I am Nuri Trianti. We are from Nuclear Physics and Biophysics Research Division, ITB. Today, I would like to present the study entitled Nuclear Energy Contribution Potential to Secure Electricity Demands with Low Carbon Emission and Low Risk of Power Plant in Indonesia. Here is the outline of our presentation. First is the introduction. Continue with the section of new and renewable energy potential in Indonesia, the nuclear energy resource and the potential in Indonesia, and then the nuclear energy potential for electricity supply based on capacity factor and base load approaches in Indonesia. And last is the recommendation. I would start with the introduction section. The government of Indonesia shifted the paradigm related to energy, in which the energy considered as foreign exchange reversed in the past. Currently, the government of Indonesia is considering energy as the capital of developed the country. The shifted paradigm reflected the presidential decree of the Republic Indonesia and government regulation. According to the new paradigm, the energy no longer considered as the source of foreign exchange. However, it invites that fundamental strength in many fields of domestic economic activity, which in turn could enhance the country's revenues. Therefore, national energy resource management towards sustainable development becomes an essential task for Indonesia to deal with. Nowadays, the fulfillment of Indonesia's energy demand still dominated by the non-renewable energy source, which originated from fossil energy. In terms of electricity generation, the data records show that among the 64.5 gigawatt installed capacity of electric power plant as of 2018, most of them fueled by fossil energy. Coal contributes to the highest energy mix, around 50%, followed by gas 29%, diesel 7%, and renewable energy about 14%. The data record implies the relative high dependency on fossil energy. Further, the utilization of fossil energy will remain the first option to fulfill the national energy demand in the future. In Rouen, it stated that the new and renewable energy should be utilized at least 31% by 2050. Further, the utilization of crude oil should be reduced to at most 29%. The utilization of natural gas shall be optimized to at least 24%, and coal will be the significant national energy source in the future if the shortage energy supply occurs. Okay, next. On the other hand, as one of the country that signed the Paris Agreement and one of 164 countries who ratified it, Indonesia commit to reduce the greenhouse gas effect, in which required the consistent development of environmentally friendly energy source. One of the potential and prospective new energy source in Indonesia is nuclear energy. However, nuclear is not priority in the development of energy source, especially for future electricity generation. The nuclear power plant considered as one of the clean, safe, and long life energy source. The development countries, including United States, Japan, France, have been utilizing a nuclear energy source for an extended period as the primary power plant in their country. Indonesia is a country with a large area, a large population, and increasing economic activity, need to consider nuclear as one of the energy source that will support and accelerate the national development in the future with the role as an environmentally friendly energy source. Okay, I will continue with the section of the new and renewable energy potential in Indonesia. The new and renewable energy, NRE, is an alternative to the energy resource which commonly used to fulfill the energy demand. Indonesia has various new and renewable energy potential, for example, hydropower, geothermal, solar, ocean energy, wind, micro hydro, and biomass. The NRE potential, which in Indonesia has, is around 431,000 megawatt. However, the installed capacity was around 6,000 megawatt. This figure shows that the NRE potential in Indonesia is quite immense. We can see here the distribution of NRE potential in each province in Indonesia. The green one is the NRE potential, and the pink one is already installed. For more details, the data shows in the figure of NRE potential in Indonesia based on the type of energy source that illustrate the hydropower has potential of about 75,000 megawatt, and then geothermal about 17,000 megawatt, bioenergy 32,000 megawatt, solar power 207,000 megawatt, wind 60,000 megawatt, and ocean energy about 17,000 megawatt. Despite the considerable NRE potential, only small portion of the capacity which already utilized for electricity production. And this is the next. Sorry. This is the next section of regarding the nuclear energy resource and the potential in Indonesia. Nuclear is one of the energy sources that are environmentally friendly and has considerable power potential. Nuclear, together with hydropower, has become the backbone of low carbon energy source, replenishing globally around 3 low carbon energy sources in the world. In general, apart from being an environmentally friendly energy source, energy also has a significant economic impact because nuclear based on a power plant has a longer service life. Hence, they are cheaper to maintain so that they are financially more competitive than other energy sources. Now we are in the area of fourth nuclear power generation, which will be safer, more sustainable, economical, and more proliferation resistant and physically secure. Indonesia is a country with a lot of mineral resources, has nuclear resources. For example, the potential of uranium and thorium, beside being discovered in Bangka Belitung Islands, uranium and thorium are also found in Bengkayang Regency, West Kalimantan, and in Seruyuan and Lamandau areas, Central Kalimantan, and also Mamuju Regency, West Sulawesi. Okay, this figure depicts the comparison of life cycle inventory result of the production of 1 kilowatt hour of electricity for essential air pollutant contributing to particulate matter exposure, the leading cause of health impact from air pollution. The emission of gas, pollutant, and particulate matter coming from the life cycle of the pressurized water reactor are much smaller than those from other energy sources. The coal-fired power plant released the highest amount of ammonia, nitrogen dioxide, and PM 2.5 in their life cycle. So according to the Nuclear Energy Institute, the United States avoided more than 476 million metric tons of carbon dioxide emission in 2019. It also keeps the air clean by removing thousands of tons of harmful air pollutant each year that contribute to acid rain, smoke, lung cancer, cardiovascular disease, etc. Nuclear energy has several features compared to other energy source. First, nuclear energy is relatively more environmentally friendly since nuclear fuel does not release greenhouse gases during the burning process. It releases the greenhouse gases only during the mining on and the processing of nuclear fuel. However, the amount of the greenhouse gases emission, such as CO2, is relatively small compared to other fuel types, for example, oil, gas, or coal. This figure shows the comparison of CO2 emission release from the life cycle of power plant with various generation methods. CO2 emission of nuclear power plants are among the lowest of any electricity generation method, and on a life cycle basis are comparable with to wind, hydropower, and biomass. Life cycle emission of coal generation are 30 times greater than nuclear. By the assumption of CO2 emission per gigawatt hour presented in the previous slide, here we estimated the CO2 emission composition in a 1,000 gigawatt hour electric production from various energy resources. The fossil energy contribute about 93.7%, while the remainder contributed by new and renewable energy source. Next is by the increase of electric production, the projected amount of CO2 emission released from fossil energy will be also increasing significantly. Meanwhile, the projected contribution from new and renewable energy is much lower than emission contribution from fossil energy. And then here we can see the new and renewable energy and fossil energy. And then next, nuclear technology also produce minimal waste in their life cycle. Here is the schematic illustration focused on the energy density comparison between nuclear fuel and other kinds of fuel. Nuclear has a remarkably high energy density. One pellet, approximately the size of human index finger, of nuclear fuel produce energy equivalent to 1 ton of coal or 2.5 tons of firewood and equivalent of 17,000 cubic feet of natural gas. From the safety viewpoint, the nuclear power plant has the highest standard of safety on their operation. This figure compares the death rate from the primary energy source. The study considered deaths from accidents, such as the Chernobyl nuclear disaster, occupational accident in mining or power plant operation, and premature death from air pollution. As shows in this figure, the death rate from energy production per terawatt hours from brown coal and coal is much larger than nuclear. Nuclear energy is by far the safest energy source in this comparison. And in this study, we aimed to estimate the potential contribution of nuclear power plant to secure the electricity demand in Indonesia. There are two key factors included our estimation, namely the power plant capacity factor and baseload. The installed power capacity is different from electricity production. Each power plant produces electricity for different level electricity production depends on capacity factor. The capacity factor of the various power plant was obtained from U.S. Energy Information Administration. And various energy resources have been used for electricity power generation, which has their own characteristics, such as the capacity factor and baseload of electricity. Baseload electricity of power plants, as well as medium and peak load approach, are one of the electricity capacity supplies based on their capability to produce electricity from power plant operation and its stability of supply over time. As we can see here the table. The baseload approach for electricity supply in general can be categorized based on high capacity factors such as coal power plant, nuclear power plant, geothermal plant, and hydropower plant. The other power plant can be categorized as medium and peak load electricity. The figure shows that estimated electricity production of various power plants based on their capacity factor and baseload approaches. Each power plant produces electricity for different level electricity production in the same power capacity, or about 1,000 megawatt, depends on capacity factor. Yeah, this figure is regarding the estimation level of contribution of various electric power plant based on capacity factor and baseload approach. Capacity factor and baseload approaches can be utilized to estimate the contribution level for various energy resource as shown in previous table and chart. And these estimation values can be obtained by normalized electricity potential production, which is corresponding to capacity factor and categorization of base load factor. The normalized energy factor was used based on the same power capacity of each energy to a level of 1,000 megawatt. And by a conversion value process from power capacity to electricity production based on their energy properties of capacity factor. Base load assumptions, energy classification, as well as of transmission and distribution. Each electricity production from all energy resource tabulated as total electricity supply. And the total value of electricity production will be used as normalized value to be used to obtain the contribution level of each energy resource in percentage. So the coal power plant, nuclear power plant, hydropower, and geothermal are categorized as a baseload electric can supply more than 60%. And others can contribute to medium load and peak load electricity. Here, nuclear can contribute 25% of the total energy supply, and followed by coal and hydropower power plants for 18% and 12% contribution respectively. When classified as fossil fuel resource contribution based on
I would
this
like to
approach.
inform you, Ms. Nuri, you have around 2 minutes for
all right.
the rest of the presentation.
Okay, I will be faster now. All right, here is the estimation level of the contribution. Okay, next I will move here. This figure is of the power plant of capacity and its electricity production. The correlation power plant capacity with electric production is obtained based on a 63% capacity factor and 10% loss of year electric production. I want to say that here we can see, for instance, 10,000 megawatt of power capacity will produce about 50 terawatt hour. And when it's required power capacity about 60,000 megawatt will produce about 280 terawatt hour. This estimated data can be utilized to predict when for the future electricity need. And then here, this figure shows that the various power plant contribution to total electric production as a function of power capacity power plant. To obtain the total electricity production, various energy resource will contribute as energy mix approach. Here we can see as the figure. It shows that the nuclear power plant contributes the highest energy level in comparing to other resource, and it will be consistently increased with increasing energy demand. When the level of contribution is kept in a constant value to total electricity supply, and in this case, nuclear contribute to 25% of total electricity supply. Moreover, when the energy resource classified as NRE, the contribution will be more than 70% of the total electricity supply, and fossil fuel will be less than 30%. And then, okay, Okay, this is my last section of my presentation regarding the recommendation. Here are our recommendation. First, it is necessary to carry out detailed geological mapping and detailed geophysical surveys in area that have potential of thorium and uranium nuclear materials to obtain accurate information about the potential of these two materials, and more major volume calculation can be carried out. The second one is, as amended in 2014 National Energy Policy Can, regarding the priority direction for national energy development, it is suggested for Indonesia to consider to use of nuclear energy and mastering the technology of nuclear power plant to accelerate the achievement of the NRE energy mix by 2050. And the last, by adopting the capacity factor of the power plant and baseload power plant approach, new and renewable energy can contribute to more than 45% of total electricity supply as base load electricity contributor, including 25% of the nuclear contributor as one of an RE contributor. All right, that's all my presentation. Thank you very much for your attention.
Thank you for your speech.